Morning, students. This is an overview of the programming language that we're going to use. We're going to use the Vex Code Pro V5 language. The V5 comes from the brain. This is a V5 Vex brain. Vex comes from the name of the company that makes them. The Pro part of it is that we're going to use the bigger language, or the text-based language, for C++. Where can you get this if you're at home? If you go to Google and put in Vex download, and then go to download Vex Code, and then go to the bottom of the page. The second one down here is the Pro. Download it for Windows, download it for Mac, and you've got the language at home. It is important that you be able to do this at home, because at some point some of you may want to come back into class and you're going to have to program with this language, even though you're using the VR stuff or the virtual stuff at home. So here's a basic overview of how it works. You have a file, and you want to go to New. And when you hit New Project, this jumps in, and you want to name it. So I'm going to call this My First Project. My First Project 01. Now notice how I did this. I named it with capital letters with no spaces. So every time I start a new word, I have a capital letter. And then I add a number to it, because I may have another first project out there. So I'm just adding a naming system that makes sense to me. You're going to save it in a file that you create under My Documents called Your Name. You put your name into it. You say Robotic Programs. That way you can download that to a jump drive and move it around, but you always know where it is. In my class, you would put it on your computers, and then I would encourage you to bring jump drives and save them to jump drives as a backup system, so you don't lose these files that you're going to work so hard on. The first one we did was called Move Forward 01. I always like to put an 01 behind it, or an 02, so if I do have multiple, I end up with 10 or 15 programs. I don't get that 1-1 or 1 thing. I have an 01, 02, 03, all the way up to 10, 11, 12. Now I have 99 spaces to put this stuff in. So we're going to create this. Mine already exists, so I'm going to create an 08, because I'm up to 8 when I do this. This is what you get when you open it up. This is what we're programming in. Notice that up here, the name that I created is sitting right here. I have an option of putting it in 8 different places. The brain, the V5 brain, has 8 different slots to program in. So that way you can run 8 different programs. So you would pick one of these and put it in there. So let's put it in the 7th position. Assuming that I've already got 6 different programs on the brain that I don't want to mess up, I put this in the 6th position or 7th position. The green is pseudocode. 2.3 talks about pseudocode. You need to read over that and do the worksheet. The pseudocode is just sort of stuff you're telling me. This is something that another human would look in your program and see and be able to tell what you're doing. The blue here, oh, by the way, if you want to do another line of pseudocode, you just go backspace, backspace. It turns green, and you can write anything you want in there. It doesn't affect the program because it's behind those backspaces and it's pseudocode. The program's not reading it. This is just for other humans. So you can write whatever you want. Happy birthday to me. So anything else you write inside of the main part up here is going to be code. The program's going to read it. So the blue up here, that is a file of information that is needed, so don't get rid of the blues. That vex.h has got to be there. It's just a background or a file, a library of information that the programmers are put in to make life easy on you. So you see that there is an int main. This is where the start, it's where the program is going to start reading. And inside of you have that green pseudocode that says do not remove this, do not remove this vex initialization, and go here. Notice that you've got this curly Q here, and you got one here. You got to stay inside of it when you write code. So what I do, I go to that vex code initialize, and I go to the very end, in which there's a semicolon. I get on the end of it, and I hit enter a couple of times, and I make a couple of spaces in there so that I stay within the curly Q. Basically what I'm doing. Once you attach a robot to it, you can come up here and add devices. We need to add a motor, 2 motors to it. those in class have a motor attached to the number 1 position. We're going to just say this is the left motor. And notice how I capitalize L and I capitalize the M because it's 2 different words, but I don't have any spaces. That's telling the program what I want to call that machine that's attached to the robot brain in port 1. I want to call it left motor. You may have the right motor. You have the option of reversing motors. This is sort of like what if you're looking at the side of the robot and you're looking at the wheels, how the motor is looking. If you think about it, your left and right motors are mirror images of each other. One of them's got to be going reverse, one of them's got to be going forward for the whole robot to move forward. That's what this is about. So I'm going to reverse my left motor, and the gear cartridge you don't have to worry about. That is something you physically change in the motor, and we're not going to change that unless you're in competition. The right motor is in port 10. That is default setting. Now you can put them in anything as long as you're programming it, it's fine. I'm going to leave this normal. Notice I have capitals. Now I'm ready to program. I have put motors in. When I come down here, the first thing I want to do is I want to tell it to wait 1 second before I start. And this will all say this, no caps, this, underscore thread, colon, 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 sleep, underscore 4, parentheses, 1000, close parentheses, and then at the end, put a semicolon. Now this is all in section 2.2. So if you go back to 2.2 and you start reading over some of the stuff, you will see the code spelled out specifically. I'm about to do the left motor one, but it's also in here, the sleep stuff. There it is. So this is the code, the way it looks. It has to be exact. You cannot make a mistake. You cannot get close. There's no close. If you don't have the code exact, it is not going to read it right, and you'll get red in the writing. If you get it right, the red goes away and it'll all work. Notice how they've got spaces between this thread and left motor and right motor, left motor and right. That's for me. If I'm walking behind you, I can look inside, see what you're doing, inside your code, see what you're doing, and I can kind of follow along, see what the mistakes are. So we're going to put spaces between each kind of command line. What is not here is the pseudocode, which we'll talk about that. So let's go back to the actual code. And this is right in 2.2. No, it's 2.1b. This is 2.1b. Go in there and read it and follow it. You have all the instructions. You really don't need this video from me because you have the instructions. And you have to read. If you can't read and follow along, then yeah, this is going to be a difficult class for you. Because I'm not going to baby you on this stuff. I expect it to be done right, and the robot won't baby you either. It expects it to be done right or it won't run. So the next thing is I want to set the left motor and the right motor up for its velocity. So I say left, I put in an L. Notice how the left jumps in there. And so I just click on it. I hit a period, got to have a period. And I'm going to hit S because I want to set velocity. And see as I work out, it's sitting right here, set velocity. I'll put it at 50, I put a comma. Then they ask me, you want it in percentage? I say yes, I close parentheses, and I put a semicolon, and I hit enter. And that's got to be just like that. Right motor, period, set, velocity, 50%, close, semicolon. And then what I'm going to do with this is I want to say what this means in pseudocode. I want to say backspace, backspace, set motors to 50%. And then above this thread, I want to say I'm tabbing. Notice how I'm tabbing off the line, and these are lining up. It's got to be done this way. Wait, backspace, 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 backspace. I'm sorry, slash, backslash, backslash, wait 1 second to start. Now I'm explaining to the reader what each one of these command lines is supposed to do. Then I'm explaining the robot the command line. Then the robot then compiles it, turns it into binary language, and off it goes. Now I want the robot to move forward, so I say left motor, period, move forward, spin, there it is, spin direction, forward. Assuming that we have set up the motors to spin in the right direction in the setup, this should work. If not, you go back and change it in the setup. Spin, direction, forward. Now obviously if you wanted your robot to turn, you would change that. You would make one of them move reverse, one of them move forward. So backslash, backslash, move robot forward. Next thing we want to do is we want the robot to move forward for a set amount of time. So let's say this, let's do this first. Backslash move forward for 2 seconds. Left motor, I'm sorry, this thread. This underscore thread, colon, 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 colon. Always do that, colon, colon, and then you sleep underscore 4 2000 semicolon, and then we want to say stop robot, left motor, stop, close parentheses, semicolon, right motor, stop. Now, I've got a program. I can download that and I can make it work. And I've explained in pseudocode, and it's green, what I want, and that's how I use this software.